right, so if you watched through the end of the previous videotape, you heard that they heard the phone ring. It was my son, and his girlfriend's parents' dog, and the dog's 18 years old, and she lived in the house during the first half of those 18 years. Has to be put down. So it's a really, really tough day, and I had to spend a couple of my minutes working with my son. Otherwise, I would have just continued in the last lesson because this material is all part of what was going on. Let me take a step back and just review what we were talking about. We talked about a regular frequency distribution table and that we don't want to get too hung up on fancy technical terminology. All right. The F is for frequency. It's how many of each score there are. The N is the total number of frequencies. N is the total number of scores. And there's always an X and a Y. The scores are always the X. The Y is always the frequency. Y is always frequency. The table goes from the highest score to the lowest score. That's important. The highest score is 17, always goes down to the lowest score, 10. The frequency is how many times a specific X value occurred. Like when we counted in the chart before and we said there were 4 15s, 0 16s, and 1 17. So I'm putting that into the table. And the sum of the frequencies is always going to be N. And the thing that's important about N and adding up the total number of frequencies is you're going to come up with a total number like 18. And then if you go back and look at the data and you make sure there's 18 pieces of data or datum in the table, then you know, okay, I got 18 and 18. More than likely, I got exactly right. I know I didn't leave any out. Okay, next. Frequency distribution tables. This is where we also, one of the last things we talked about in the last video, a third column can be for P equals F over N. Now, if I'm a kid sitting in class, all of this technical talk is starting to get on my nerves. It's starting to drive me crazy a little bit. This is the kind of thing that math majors, they're very comfortable with this, but most people are not math majors, so they start looking at this and they have a negative reaction. Don't. This is a bunch of technical talk for the proportion is the part over the whole. And that goes back to elementary school percents. The proportion, P, is the part, the specific frequency, like there were 4 15s, there were 0 16s, there was 1 17, out of the total number of them. So the proportion for the 15s would be 4 out of, I think there were 18 scores, so 4 out of 18. For the 16s, it would be 0 out of 18. For the 17s, it would be 1 out of 18. You can also add a fourth column if you want, and you could convert that to a percent. Now, here's the fancy math terminology for you. A fourth column can display the percentage of the distribution corresponding to each X value. The percentage is found by multiplying P by 100. The sum of the percentage columns should be 100%. All they're doing is converting a fraction to a percent. It's like saying, I've got 7 out of 100, that's 7%, or 1 out of 4, that's 25%. That's all the technical talk is doing, okay? So don't be intimidated by it. When a frequency distribution table lists all the individual categories, the X values, it is called a regular frequency distribution. So in other words, list all the X values, you got a regular distribution. But sometimes you want to group them, okay? When that happens, you have a set of values that covers a wide range, a set of scores that covers a wide range of values. And like, let's say we did every score from, for argument's sake, 0 to 100 on a test. Well, that's a whole lot of scores to put in a table. So we might group them 0 to 10, 10 to 20, 20 to 30, or maybe even 0 to 20, 21 to 40, 41 to 60, 61 to 80, 81 to 100. So that's all this is saying is when you have this ton of scores, maybe you want to group it instead, okay? That's what the grouped frequency distribution table is all about. And the group frequency distribution table, in the group table, you set up intervals rather than individual scores. The intervals all have the same width. So like you can't have an interval from say 20 to 60 and then 60 to 65 and then 65 to 75. You can't do that. All of them have to be the same width. 20 to 40, 60 to 80, 80 to 100, that kind of thing. Each interval begins with a value that is a multiple of the interval width. The interval width is selected so that the table will have approximately 10 intervals or however many that you think it should go. So let's look at a good example. I think this will make you understand, okay? let's say that we're looking at some HDL cholesterol levels of 20 to 29-year-olds or some serum numbers, okay? Can you imagine putting that all in a single table? Yowza, that's a lot of scores. The guess is that grouping this data is a much better way to present the data. All right, I do want you to note, that's in the upper right-hand corner, that there's a total of 40 scores here. There's 8 columns and 5 rows. So when we do our table coming up, we better get n equals 40. Okay, so now what we have is I made some intervals. 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79. Then I go through and I count the frequency for each one. This means there are one scores from 20 to 29, 6 from 30 to 39, 10 from 40 to 49, and so on. That's what we did before. So you should be comfortable with that. Now, P equals F over N. What is this all about? Okay. Well, rather than write a fraction, they convert it to a decimal, and that's really easy. Okay. Notice that N is 40. N is the total number of frequencies. If you add up all of those frequencies, you get 40. Now, on your handy-dandy calculator, I want you to take the frequency for the interval from 20 to 29, it's 1, and divide it by 40. What do you get? 0.025. What if you take the 6 and divide it by 40? What do you get? 0.150. So all they're doing for each of these is saying, hey, what is the proportion out of the whole? Okay, the part out of the whole. So you just take the frequency 1, divide it by 40. Then 6 divided by 40. That's the 0.150. Then 10 divided by 40. That's 10 divided by 40 is 1 out of 4, which is 0.25. 14 divided by 40, 0.350. And so on. And that's how you generate all of this proportion here, okay? You just take this particular frequency and divide it by what we have going on there. Let me pause this for just a minute, or let me stop it.